All right, it should be live. But my computer totally reset, so I need confirmation that the audio actually functions. And if the audio level is good, let me know if that's the case. Oh, it's going to be hot in here. I think I want to turn on the aircon. Okay. What do I do? How do I do this again? I know my camera's a little wonky, and now that I tell you this, you're not going to. We hear you, but you don't hear us. No, it's true. It's true. So my wife rated my camera lens to take pictures of the aurora, and weren't never right. So, well, Chad can fix it in post. No audio. Someone has been in too much sun. No, I have been in exactly the right amount of sun. I just turned red. You'll see my color will change throughout this show. I might turn redder. I might turn less red. It just depends. Okay. What do we do? Right. So we got back from Japan, which was amazing. 2 weeks in Japan. I released one Space Bites, and the rest of the time was just exploring the country, and it was absolutely fantastic. It was better than I want to go back right now. So the technology there is amazing. The trains are so fast. Everything is so well organized. The food is so good. The hotels are so clean. The whole place is so clean. Everybody's so nice. It was absolutely fantastic. So we had a great time, and my son had a great time, and it was great to see him, now an adult, now a young man, be able to do a lot of traveling on his own. So he was able to just ditch me for a day and go and hit a bunch of temples that he wanted to see while I had to get some work done. So I highly recommend it. If you're like, oh, I don't know about Japan, it seems like it's a tough place to travel. It is not a tough place to travel. It is the easiest place to travel that I've been to so far. That all the signs have English on them. All of the machines that you have to interact with are very intuitive and also have English options. Everything is just so easy to explore in Japan. So if you were like on the fence, you're like, I don't know, would I move there permanently? Yeah, I would live there. I'd live in Japan. I know it's very different for people who are Westerners who are going to try to live there, and you sort of have a hard time fitting in with the culture. But also, I've heard they've sort of opened up the floodgates on immigration. They're quite proud of their immigration. So yeah, I would totally live in Japan at this point. Yeah. Okay. Yeah. No, I didn't run into Ellie in space. How was the Canadian dollar to exchange rate? It was good. We were like 130 for Canadian dollars. So any amount in yen, I would just sort of knock off 2 zeros and then make it a little lower. So if an onigiri cost 130 yen, then it was $1, which was bonkers. How, like the best ramen I've had in my life was like 800 yen. And so it was like $6 Canadian, when our local ramen place by an authentic Japanese woman who knows how to make really good ramen is like $17. So it was, it was good. Okay. So you look tired. Oh, I'm just old. Like I'm a 52-year-old man. So unfortunately, when you get old, age catches up with you and your skin starts to hang, your face gets blotchy, things happen to you. So, I'm not a 20-year-old. All right, let's get cranking. So I actually don't have any prepared questions this week. So we're just going to get your questions. So go ahead and add your questions. All right. Here's me, Chad. Do you drink milk frequently? No, I'm vegan, so I don't drink milk. Yes, I am recording. Oh, I guess I should do it again. Okay. There we go. And then hopefully there should be some questions. How do you know if one of your questions is going to be answered? Surprise? You hear me say your name, and then I answer the question. But yes, you'll be surprised. So Brad P., how loud would the sun be if there was an equivalent medium for sound to travel through space that we have on Earth? I don't know what the sun's seismic frequency. Because there's a couple of different kinds of waves. There's the P waves and the S waves. But what is the frequency? Between 1 and 5 millihertz. Yeah. Yeah, I don't see anything other than that. Favorite moon crater? Lunicod 2. I mean, I don't know the names of a lot of the moon craters. Aristarchus. There's like the Lunar X, which is pretty cool. It's so funny. Everyone's like, you're so red. So this is always the way I am. This is just like my face, especially it's more so in the summer, especially when the temperatures turn really hot, and it's very hot right here right now. And so I'm in the sun the amount that I normally am. I always use sunblock. I just turn red. So imagine you were going to give a presentation in front of 1,000 people, 50,000 people. You're going to stand in front of 50,000 people and you're going to give a presentation. And your body responds to standing in front of 50,000 people and having to give a presentation. There is a certain amount of nervousness. There's a certain amount of like you just get kind of flushed, and different people's bodies respond in different ways. And the way my body responds is my face turns red, and it's always been the case. So what you're seeing is not that I am sunburnt, although I might be a little sunburnt because I was out in the sun cutting brush today, and I didn't put sunblock on, but I wasn't out for very long. But it's just what happens. And then it goes away. Definitely if I drink alcohol, I get it. So, yeah, there you go. Pinkish in tones of purple than red. Sensitive skin. Um, so I need more questions. I apologize. I don't have any prepared questions. Well, I've got one. Let me see. But I don't know the numbers on it. N25 shoot, was that an anomaly or a test? So Jean Doppler, the N25, that's the New Shepard 25 that just landed today. Yeah, so there was a problem with the one of the parachutes. There was a problem actually when they landed. They landed in brush and they couldn't get the doors open, and so they had to wait and get help. Is dark matter observed only at the farthest reaches of the universe, or is there dark matter closer? Okay, we'll do this one. Ryan, is dark matter observed only at the farthest reaches of the universe, or is there dark matter closer? So dark matter is observed at all scales in the universe. It's seen both relatively close by, like when you measure the movements of the stars within the Milky Way, and it's also measured at the farthest scales that we can possibly perceive, which is in the cosmic microwave background radiation, and everywhere in between. So we see the effect of dark matter through the movements of galaxy clusters colliding with one another. So I'm going to run through the various lines of evidence that tell us that dark matter is a thing and sort of give you a sense of the scales for where we're seeing these lines of evidence. So the one that's kind of the closest is the movements of the stars in the Milky Way. And so when you envision all of the stars going around the center of the Milky Way, compare that to the planets that are going around the sun in the solar system. So you've got these planets, for example, Mercury is going the fastest, it's going over 40 kilometers per second, and then Earth is going 30 kilometers per second around the sun, and Neptune is going like 5 kilometers per second around the sun. You've got this drop off, this very linear drop off as you get farther and farther away from the sun. And this is what you would expect if you have a bunch of objects that are orbiting around some gravitational center. So the sun with the planets going around it, that's the way you sort of see the change in the velocity of the planets that are orbiting around it. Now, if you do that same measurement of the stars going around in the Milky Way, the stars that are very close to the center of the Milky Way, the ones that are quite close to the supermassive black hole, are moving very quickly. And then the speeds slows down as you get farther away from the center of the Milky Way by a little ways. And then something super weird happens, which is that the speed doesn't change. So even though you're going farther and farther away from the center of the Milky Way, the speed remains exactly the same, or roughly the same, around 225, 250 kilometers per second. Chad, you can cut that out if I got the number wrong. And they don't drop off in the way that you expect. And so how is that even possible? The only way that you can have that be possible is that it's not that all of the stars are orbiting around some center of gravity the way it is in the solar system. It's if the stars are embedded in some much larger thing that is just turning, and the stars are turning inside of that thing. And so when you run the math to say, like, how much stuff would it take to get the behavior of the stars as we see them here in the Milky Way and in every other galaxy, you need about 10 times as much mass in the Milky Way as what we can perceive. When you count up all the stars, you get 10 times as much mass. So that is affecting the sun. Now, we don't know if dark matter, if it is like a particle, that there's dark matter particles in you right now today. There's dark matter particles that are moving around in the solar system. There could be dark matter particles. Or maybe there's primordial black holes that are 1,000 times the mass of the sun, and they're tens of light years apart, but they add up on average to making the Milky Way move that way. And so that's very close. And then when you look a little further out, actually the other one is that the speed of rotation of galaxies is too fast. So they should be tearing and shearing themselves apart. But for some reason, the galaxies are able to keep themselves together as if there was more matter gluing them together than what we can perceive. And then when you look farther away, we can see gravitational lensing. So when astronomers map the universe very carefully, they're able to see these distortions of light, where light has made this journey from a distant galaxy to our telescope, but it's been curved and bent and warped. And you can actually, like, imagine you're looking through water, like water that's rippling at, say, trees or something. You're lying on the bottom of a pool, you're looking up, there's trees above you, and you're seeing the trees are getting all kind of warped. And so you know that there is water in between you and those trees, because you can actually measure. And you could measure the depth of the water if you sort of knew the true shape of those trees and you were able to measure the warps and the changes. And so when astronomers measure just very carefully the structures of the universe, it all looks like it's in a bit of a funhouse mirror, warped and wobbled. And then you can calculate the amount of gravity that would take to distort the path of the light as it's moving from more distant objects, to be able to tell you and match what you're seeing. Once again, you need about 10 times as much mass to account for those kinds of changes of the light's path to be able to get to you. And then you've got things like the bullet cluster, where you've got giant galaxy clusters that are colliding together. And what you get is the mass that is the distorting mass seems to pass directly through. As two galaxies are colliding with one another, the stars pass right through each other. That extra distorting mass also passes right through, but the gas and the dust kind of collides in the middle and piles up and heats up. And so we know that whatever this thing is, it seems to hang out with the stars and can be separated from other things. And then we can actually see examples of dark matter where we can see galaxies. When you sort of look for the warps and the wobbles around a galaxy, you don't see it. So there are galaxies that have a lot of stars, but they don't seem to have any dark matter in them. And then you look at other galaxies where you can see this distortion of space, but there are almost no stars inside of it. And so it's a galaxy that's made almost entirely of dark matter. And then at the farthest distances of the universe, we see the cosmic microwave background radiation. And essentially the anisotropies, the changes in temperature that we measure in the cosmic microwave background radiation, could only exist if you had an amount of dark matter in the universe that matches all of the other observations. So there are so many observations for dark matter. Nobody knows what it is, but that's fine, right? Like, this is how it starts. You see a bunch of stuff and you say, that's weird, and then you measure it. So back to your question, dark matter impacts us very slightly at our galactic level. I guess no. So back to your question, dark matter affects us at our galactic level, at the Milky Way's level. So it's whatever it is, it's around us, and also seems to have an influence across the entire universe in every direction as far as we can see. Brad P., any updates on the farting rover? There are no updates on the farting rover. But obviously I missed the joke. I was like struggling to find a joke, and people told me, whoever smelt it dealt it. Like, Curiosity detected the methane, and Curiosity was the one that made the methane. So obviously that was the joke, and I didn't get it. And I feel bad. Is that? Oh. Okay. Vincenzo R. How accurate do you feel MOND is to explaining the gravity problem the standard model seems to have? I'm a bit fuzzy on what MOND really says. So MOND is modified Newtonian dynamics. It is another explanation for dark matter. And the gist of MOND is, like all those observations that I mentioned before, that those all assume that gravity works the way we understand it at the local level, kind of like Newtonian, and includes all of the relativistic stuff introduced by Einstein, that we understand how gravity works at various scales in the universe. But what Mond says is that, well, maybe we don't completely understand how gravity works at the largest scales, that when you want to look at scales that are even greater than, say, that which is affecting stars interacting with one another, then you can put in a fairly straightforward additional factor into your gravitational calculations, and suddenly it answers many of the same questions that the particle idea for dark matter does. That if gravity worked a little differently than we understand, then you would see galaxies, stars moving in galaxies in the way that we see them, that you would see galaxies not tearing themselves apart as they rotated. You would see all of these various observations. But there are some problems. Like, there's a lot of other observations, like, say, that gravitational lensing that I mentioned. It's really hard to say, well, why would one galaxy have a lot of this extra factor for gravity, but this other galaxy has almost none? What is the difference between those two galaxies, right? If we know the total mass of the stars in those galaxies, then we should know how much of a gravitational interaction they should have. Now, there are a lot of people that still think that Mond is the answer, but they're having a harder and harder time these days being able to convince the rest of the astronomy community. And so, this is how science works, that an observation is made, someone says, that's funny, and then people try to explain it, and they come up with theories, and then they search for, they make observations and find out whether or not those observations match back against the original theory and provide more evidence one way or the other. And it's been this long process over decades and decades where the evidence is growing that dark matter is some kind of particle, and the evidence is declining that dark matter is just that we don't understand gravity at the largest scales. But Mond has not been completely disproved, and so people come back around almost every week with a new paper that incorporates Mond and comes up with some new ways to account for some of its issues. People address them in the scientific literature, and the conversation goes back and forth. I mean, the other one that you can't rule out is primordial black holes. That there are black holes left over from the beginning of the universe, and they are dark matter. There is no particle. There are just black holes. Does that make you feel better? Damon Yates, thoughts on the lack of impact from the G5 sunspot emissions that hit Earth. So when I'm recording this, we are at the tail end of a series of very powerful solar storms that struck the Earth. I think over the course of a couple of days, we got 8 X-class flares. Maybe it was 6 X-class flares. And the X-class are the most powerful types of flares that the sun gives off. And when an X flare is directed towards the Earth and you get a coronal mass ejection, you get particles coming from the sun interacting with the Earth's magnetic field. You get auroras seen in regions that maybe you wouldn't normally be able to see them. And you also get disruptions in our communication, electrical problems, satellites can go down. So it can be both wonderful because you go out in Florida and see the auroras, but it can also be a little scary because, some of your electronics can have problems. And we know that there are much, much worse versions of solar flares that have hit Earth in the past. The most famous of these is the Carrington event, which hit Earth in the 1860s and was so powerful that people saw auroras around the entire planet. Telegraph poles were lit on fire, and this was a largely non-technological society at that point, and yet already just the faint bits of technology that people had were starting to fail. Now, from what I understand, the Carrington event was an X45, which is an extremely powerful solar flare. And the most powerful of the recent grouping that we had was X8.6. So And I believe that sort of the process goes up by orders of magnitude. So an X45 is a dramatically more powerful flare than an X8.6. And so you're just not going to get the same kind of damage. We theoretically should be getting these Carrington class events every 1,000 years or so. And scientists have been able to look through tree rings to see evidence of past solar flares. And they've found some really incredibly powerful events that have happened, say, for the past 10,000 years. I think there's 6 events. And the scary thing is that the Carrington event isn't one of them. So the Carrington event wasn't powerful enough to sort of have the evidence of that event be locked into the tree rings. So back to your question, any thought on the lack of impact? We get hit by solar storms all the time that, a 8.6 is nothing. We saw one about 20 years ago. We've seen more powerful ones hit Earth, and we know what the effects are. There can be local damage where satellites can go down or some electrical grid can fail, like the one that happened in Quebec back in the 90s. But just in general, it's just not a severe enough storm to cause significant problems. So we're approaching solar maximum. We should see many more of these solar storms over the coming months, leading up to whenever solar max peaks sometime next year. So this is your chance to see auroras. I wouldn't be worried at all about what effect. And I know, I was arguing with people in my comments saying, this is it. This is the end of the world. No, it's not. It's not. It's fine. Just like the asteroids aren't going to be hitting Earth, that, there are channels on YouTube that are trying to freak people out for clicks. I'm not one of them. I'm trying to calm you down for clicks. I'm trying to educate you for clicks. So, powerful flares happen all the time. No big deal. Enjoy the auroras. Tom Hodder, if planet 10 exists and is 300 astronomical units away, would it be visible with light telescopes? So I like that you said planet 10. I think, the Pluto as a planet community are going to appreciate the fact that you're calling it planet 10 and not planet 9. Planet 9 is the planet that Mike Brown and Konstantin Batygin are proposing as a maybe Earth-sized world, maybe Neptune-sized world orbiting in the outer solar system, and it's influencing objects in the Kuiper Belt. And no one has directly observed it yet, but we can direct its influence. Nobody has directly observed it yet, but based on its influence, it's kind of narrowing down the search space for where this thing could be. And the reason it hasn't been found is because it is very dim. So there are plenty of surveys of the entire night sky that have been done to a depth, a sort of dimness of object that would have turned up planet 9 at a specific brightness. It hasn't been found. More detailed searches at even sort of fainter brightnesses have been done in the plane of the ecliptic, in the places where Mike Brown and Konstantin Batygin are proposing this object might be. But a telescope that can make this kind of observations, field of view, is very, very small, and these telescopes are very, very busy. So you can't just say, listen, we need to use the James Webb Space Telescope, and we need to search the entire plane of the ecliptic for a mysterious object that is out there. Sorry to anybody else who ever wants to use James Webb ever again. So just to give you a sense, right? The Hubble Space Telescope has been operating for almost 35 years now, and it has probably imaged 0.5% of the night sky. 0.5%. So give it another 200 years, and it will have imaged the entire sky. It's it's a big sky and it's a very small tube that is trying to look at it. And so just there are telescopes here on Earth and telescopes in space that can see to ludicrously faint magnitudes if they know where to look. And this is the problem. Nobody knows where to look exactly. So we're waiting on the next great observatory to come online. And this is Vera Rubin, which comes online in 2025, not 2015, as I said in Space Bites. So next year, Vera Rubin comes online. And this telescope is going to be doing all sky observations from the southern hemisphere, and that will include the entire plane of the ecliptic, all the places where the planets go. It's going to be able to observe to a very faint magnitude, and because it's going to be observing the entire sky every 3 nights or so, any object like Planet 9 that is slowly moving through the sky, bip, 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 you're going to see its motion every 3 nights. It's going to be this little dot that appears in the next image, the next image, and the next image. It's out there, or it's not. Right? And so if Vera Rubin does its observations and it doesn't find anything, then we know that there's some other interesting influence that is causing the motions of these Kuiper Belt objects. And there's a lot of really great ideas, like maybe a rogue planet passed relatively close to the solar system and disturbed all these planets. Maybe there's just this combined influence from all of the stars in our neighborhood of the Milky Way that is causing this change in distribution of the Kuiper Belt objects. So whatever the answer is, it's going to be really interesting. Now, would you be able to see it with a telescope, like a backyard telescope? And I would say no. If you have a very powerful backyard telescope, you can see Pluto. But you would need something that is like a professional science grade telescope, something in the several meters across, to be able to see an object as faint as how faint Planet 9 is going to be. But the most powerful telescopes on Earth, the Very Large Telescope, the Extremely Large Telescope, and of course space-based telescopes like Hubble and James Webb will be able to see it. Like, unless it's incredibly dark and incredibly dim, we'll find it. Vera Rubin will find it, and then everybody else will observe it so much. Vera Rubin sandwich. Moonwalker. Does a scientist always get exclusive use of James Webb, or can multiple scientists use it simultaneously if what they're observing is pointing in the same general direction? So the time for James Webb is broken up into kind of 2, maybe 3 broad categories. So the first category is dedicated time. And the important thing to remember here is that using the James Webb telescope is completely free. So anyone on Earth from any country can access James Webb and use it for free without having to pay anything. Now, you're going to have to be an astronomer or a scientist. You have to make a good case for them to grant time on the telescope, but there's a process for scientists to be able to go through this. And so the first bucket is the people who want to make some very specific observation. Like, think about how David Kipping wants to search for exomoons. He's got a very specific planetary system that he wants to point at a very specific time when the planet is going to pass in front of its star. That's the moment to try and observe to see if there are exomoons there. And so the telescope team has granted the time, and in that exact moment, James Webb will turn and point and gather that data. And I don't remember the exact percentage of the time, but let's say a third of James Webb's telescope time is taken up by these direct observations. And so the astronomer who has made the request, made the proposal, then gets a login to a website where they can download all of their data. And they've got a year to have exclusive access to the data that they requested to be able to write their science paper and be able to publish their results. And after that year comes up, all of their data is freely available to the rest of the internet, and anyone who wants can look through that data and see if they can make their own discoveries and observations. The second tranche of observing time is for surveys. And so there's a bunch of surveys, one called JADES, one called SEERS. There's a bunch of stuff that's being done inside the solar system, and extragalactic stuff, planetary systems. And with these, there's a list of targets that are agreed upon in advance. Essentially, James Webb is making its own mini version of the Hubble Deep Field. It's got a specific region of the sky. It's taking a bunch of images, and then those images are being freely accessible to astronomers anywhere. You can go, log in, gather the data, do with it what you will. And the last part of this is called discretionary time. And so there's some time that's left over, and it's a fraction of the leftover time that is available by the committee that's running James Webb if something exciting comes up that needs to be observed right away. So you think about comets or interstellar objects or interesting storms that happen, or if a supernova is seen and requires observations, then James Webb can join in the fun and be able to, be turned and pointing at that object. Now, if it was right in the middle of when David Kipping was trying to make his exomoons observation, then things are going to have to be shuffled around. Time is going to have to be reallocated depending on what happens. But yeah, so in general, either you get exclusive use to the data based on what you've observed, but then you have to share the data with the rest of the astronomers after a year. It's called an embargo. Or you are part of a larger survey, and multiple scientists. Everybody can access the data immediately. Eco Duras, have you ever been to the NSS International Space Development Conference? I have not. Dougal, will the Canadian team win the Stanley Cup? I'm ashamed to admit that I don't watch hockey. John Keeler, what do you think about the all-in-one telescope? So I just did that a couple of episodes, maybe 2 episodes ago. I went into pretty great detail. So my general opinion of the smart telescopes is they're awesome, but they're expensive. And the optics, the pictures that you take are not as great as what you can do if you put together your own setup. Sabina Hassenfelder got an asteroid named after her recently called 16648 Hossie. When are we going to get one named after Fraser Cain? I don't know. Why don't you Google search asteroid Fraser Cain? See what you find. Might be that I already have one. Rectal Rooter asked a horrible question. What if NASA budget gets super cut? What missions would you be willing to give up? I can't even do it. I mean, everything is already sliced bare to the bone right now. Are you sure you're not Canadian? I know. I'm ashamed. And I feel that humiliation every day. Sorry, just looking. There's submissions that aren't focused on. God, there's so many. Sirius K. Lee, will the question show have the summer hiatus canceled, or is only that astronomy cast? Yeah, we go on hiatus for the question show as well. So there are going to be 5 more question shows, and then we're on hiatus from July and August. We'll still do Space Bites, and we'll still have interviews, but we have a plan for the question show, which is that We're going to go through the overtime segments that we recorded last year, and we're going to put together a clip show of all of the stuff that nobody saw. So, like, unless you show up for every single live show, like, Zapfan, and John Suffield and Sears K. Lee, then you won't have seen any of this content. And so we'll probably put that together and sort of find all the best stuff. And they're a little more ranty, I think. So we'll see. More dark matter. Michael Brown, aren't neutrinos a form of dark matter particle? So neutrinos don't explain dark matter, but I really love neutrinos as a way to wrap your mind around what kind of particle dark matter is. And so when astronomers were starting to figure out how fusion worked in the sun, and they did the math, and they said, okay, you've got a bunch of hydrogen atoms that they're getting smushed into helium atoms and they're releasing gamma radiation. If you carry the one, then there's a little bit of mass that is missing. And they said, so there should be some kind of particle that is being released that is getting rid of this remainder of the fusion process. And yet we don't see these particles. We don't see little bullets flying out of the sun, tearing everything apart. What's going on? And so they searched for this object, and they built larger and larger detectors, neutrino detectors, and realized over time that these particles just never interacted with anything. And it wasn't until they, I think, had built this giant neutrino observatory next to a nuclear reactor, and they had a high concentration of neutrinos that were passing through it, that they were able to start actually detecting the occasional interaction with a neutrino and the water. And we now know that a neutrino will gladly pass through a light year of solid lead without interacting at all, and that there are countless neutrinos streaming through your body right now, and yet you don't feel them because they just don't interact. And so the kinds of detectors that are required to find neutrinos are a cubic kilometer of water ice down in Antarctica. That's the IceCube facility. And so we already have an example of a particle that is produced by fusion, by supernovae, by various other events that happen in the universe that don't interact in any way. They are not detectable through their interactions with electromagnetic waves. They're not detectable through their gravity, but they're there. And it was finally with the right kinds of experiments that were developed. And it took decades for people to finally go from this theorized particle to this actual particle that was found. And dark matter is kind of exactly the same in that process. Now, its behavior in the universe is very different. It, doesn't interact at all through electromagnetism, despite, it doesn't interact. It's not getting caught in giant neutrino detectors, although people have been trying. But we can definitely see its influence through gravity, and it doesn't interact with itself, which neutrinos don't interact with themselves either. But where things kind of differ is that neutrinos are moving just shy of the speed of light. So they're considered hot. And whatever dark matter is, it has to be moving slow because it sort of holds itself together in these giant blobs around galaxies. And if it was moving at close to the speed of light, then it would be escaping the gravity of the galaxy and it would be flying off into the universe. And so whatever this particle is, it doesn't interact with regular matter. It doesn't interact with itself. Dark matter doesn't collide with itself, but it's slow moving and must be massive. And so over time, that's what astronomers have been able to work out so far. They've been able to narrow down the search space. But no, neutrinos can't account for dark matter because neutrinos are hot. They move too fast. They don't explain the observations that are made for dark matter. So there's another totally mysterious particle in the universe out there for us to find. Chris rhymes with this. Has an interview you've taken part in ever gone off the rails? You lost access to whatever. I don't understand the question. Like an interview that I've conducted has gone off the rails, or I've been interviewed and it's gone off the rails. Has there ever been an interview that has been so bad? Yes. Yes, there have been interviews that have been so bad that we have not released them. I'd say there's probably 5. Not for content, but for audio quality, video quality. That's the main reason. But I'm pretty careful about who I decide I'm going to interview. So we had a couple of interviews on the Weekly Space Hangout where I don't know how the person became the guest on the Weekly Space Hangout, and I could sense that the conversation wanted to veer into woo-woo territory, and so I locked it down and finished up the interview and sent them out the door. So I want to see the 5 interviews. That's the thing, right? Is like we get like I'll do an interview and I don't know how good the quality with their audio quality is going to be, right? And so I will sort of set up the interview and then meet with them, and then it sounds okay to me, and so I'll conduct the interview. Or I feel like an asshole if I want to ask them to turn down, like stop the interview and we'll do this another time because they've taken the time. I feel like a bad person, and I should follow my gut, which is nope, the audio quality is terrible. Stop the interview right now. Send them a microphone and try again at another time. And it'll be a much better experience because whenever we post, like you should see the nasty comments that we get on the YouTube videos when we have audio quality that's not very good. People just shit on us. And so I know that, for some people like, oh, I want to hear those interviews. No, you don't. You don't. They just sounded too awful. We had to pull it. Now we've got an interview that's going to come out tomorrow, and it was a fascinating interview, and it's one of those examples where the original audio was just awful. And so we recorded, did the interview, we did what we could to clean it up, and I talked to the guy, and I was like, this just sucked. We can't do it. And he was like, well, let's just do it again. Just send me a mic, and we'll do it again. It'll be like it never happened. And so we did. And so I sent him a microphone, and we re-recorded the interview, and the audio was much better. And in fact, I now had practice. And so I knew the kinds of topics that he was into, where he was going to be very strong in. And so I was able to then conduct an interview that sounded really good. And so I think hopefully, that's the perfect world. The perfect world is I encounter a person, I realize the interview is steaming pile of garbage, audio wise. I send them a microphone. We, right away, I stop the interview and go, nope, we can't do this anymore. I'm going to send you a microphone, and then wait till the microphone arrives, and then we conduct the interview. So that's the hard lesson, the bitter lesson of doing interviews. Love swearing Fraser. Yeah. See, this will never be seen, and it won't even be heard because we won't put this into the overtime for the patrons. So AI may be able to clean up the audio. Yeah, maybe in the future, but we're not there yet. That'd be great. Australian. the aurora here in Australia look pink and the northern lights are very green. Is that true? And if so, why? The color of the auroras can be anywhere from pink to purple to green to blue, red, definitely. And so they can sort of run across the entire color spectrum. And it's not whether it's an Australian thing or whether it's a North American thing. It just depends on what you see. So the most amazing auroras that I've ever seen were green, just only green, and just a amazing shimmering curtain of green that went all the way across the entire screen, the sky. Oh, someone's been spending too much time in front of screens. The most amazing aurora that I saw was pure green, and it was just this curtain of green that went all the way across the sky and shimmered. It was incredible. And yet other times I've seen red auroras. I saw one that was like a line of red that went just all the way across the sky in this sort of line that just hung there. And we'll show you some pictures. We shared them in Space Bites, but I was in Japan. I wasn't able to see it, but my wife was back here in Canada, and she was able to watch the aurora, and she got all of the various options. She got some green aurora, and she got some sort of pinkish red aurora with bits of yellow in it. Amazing. And these are pictures just off of her iPhone, and yet she was able to see them with this level of clarity. So this last batch of auroras, like if you missed it, like me, this was a really great chance to see auroras, and hopefully we'll get a chance to see more. So no, there's no rhyme or reason to who gets which colors where. Sure. Lily Rose, what is the Drake equation and how do you think it goes with the length of the universe? So the Drake equation is an equation that was put together by Frank Drake, and he did this as a sort of talking point for a conference that a bunch of scientists were having, where they were trying to consider and work out how many technological civilizations there are out there in the universe. And so Drake proposed 6 factors. And I forget the exact precise factors, but the gist is the number of stars with planets, habitable planets in the Milky Way, and the percentage of those planets that are within the habitable zone, and the percentage of those that have life that have emerged on them, and the percentage of those that have had a technological civilization, and the percentage of those that, or the length of time that those lifetimes, those civilizations last, and the amount of information they've communicated out into the universe. And then if you crunch all those numbers together, you can calculate the number of communicating civilizations that are in the Milky Way. And people come up with different numbers. Like, so I found 1,000, I found 1, I found 10 million. And so the problem is that, yeah, we might know what percentage of stars have planets, what percentage of those stars are terrestrial in nature, what percentage of those are in the habitable zone. And we're getting to that part. But it's the, how often does life form? We don't know. We could be anywhere from every single planet life forms to it happens 1 in a quadrillion times, which means that we are the only life in the entire observable universe. And so we just don't know. And when you look at the Drake equation, you can magnify and multiply it. You can think, well, like what percentage of those habitable planets have plate tectonics, which is required for multicellular organisms? What percentage of them have a large moon in a stable orbit to keep its orbital tilt from being unbalanced? And what percentage of them are located within the habitable zone of the galaxy? And so there could be another 1,000 factors that will influence the chance of an intelligent civilization arising and communicating in the universe. But we just don't know those numbers. That one number on how many worlds has life arisen is still a mystery. And until we find any other examples of life out there in the universe, we just don't know. And so the unfortunately, as cool as the Drake equation is, and as like tantalizing a thing that it purports to deliver, right? Just run a bunch of numbers through and you will get the number of communicating intelligent civilizations in the Milky Way. Just like that. Now we just have to find them. Well, the problem is that it's garbage in, garbage out. And so if you're just going to guess, then why do you need an equation to guess? Just guess. Come up with a number, whatever number makes you the happiest. So unfortunately, more data needed. Edward Hinton. They say that you wouldn't know that you've passed over the event horizon of a huge black hole, so you could see the event horizon of a black hole and partially put your arm over it. What would happen? So for the small black holes, the stellar mass black holes, then the tidal forces are so extreme that they're going to tear your arm apart. They can tear your whole body apart as you get too close. So you will know that you are approaching the point of no return when you have been stretched into a stream of goo that is now orbiting around the black hole and on its way to go in. But for the supermassive black holes, the ones that have millions or maybe even billions of times the mass of the sun, the gradient of the gravity that you experience is so low that you can fly your spaceship through the event horizon and not even feel it. And yet there is no escape. You have passed the event horizon. You can never come out. And so what would happen if you flew right next to the event horizon and you put your arm into the event horizon? Well, the part of your body that is outside the event horizon could theoretically, if you're able to move your spaceship at close to the speed of light, could escape. But the part of your arm that you put into the event horizon is going into the black hole. It is a one-way trip. You do not come back out. So it doesn't matter whatever you try to come up with. Like, take a camera, put it on a long pole, stick it down into the event horizon, and then pull it back out. And you're like, there's no camera there anymore. It's just gone because nothing gets out. All roads lead to the singularity, and there's no way around it. So just inside the event horizon, going into the black hole. Outside the event horizon, there's a chance you could escape. Okay. Yeah, obviously the photon ring will fry you. Like, there's a lot of other bad things that happen to you as you get close to a black hole. What if you flex first? Okay. So I've got to do a little bit of administration, and then we'll move on to the overtime segment of this week's question show. So you've got like 2 minutes if you want to go to the bathroom, grab a snack. Welcome to, I got to do hold on a second here. Is dark matter close or far away? How dangerous are these recent solar storms? And why do the auroras look the colors they do? No, that's not a good one. All right. And could we make a better Drake equation? Let's do that. Is dark matter close to us or far away? How dangerous were those recent solar storms? And is there any way we can make the Drake equation better? All this and more in this week's question show. Welcome to the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops into your brain, just write it down. I'll gather them up and I'll answer them here. All right, let's get into the questions. I hope you noticed the Star Trek planet name that appeared above my shoulder. This is a way for you to vote, for you to tell us what you thought was the best question, best answer, combo, whatever you thought was best. So the winner this week was for Dr. Whale Al-Rifai, and asking what would happen to a spaceship that was going asked what would happen to a spaceship that was going at 50% the speed of light and hit a piece of sand. So thank you everybody who voted and chose that as their favorite question answer. Now we will put a different Star Trek planet name above my shoulder for each of the questions, and we'll put them in the show notes, and we'll put a list down below. And so just go ahead and put the name of the question down in the comments down below, and that's a way to vote, and we'll count them up next week and we will celebrate again. If you want to support the work we do at Universe Today, consider joining our Patreon club. Now, there's something that I want you to know, which is that you don't have to give us money to be part of Patreon. You can actually join our Patreon for free. You can subscribe, and then you'll get notifications on all of the various things that we post to Patreon. And actually, the vast majority of everything that we do is available for free. Sometimes we release it a day or two early to the patrons, but most of the time, everything is just freely available. So go to patreon.com/universetoday to join for free. Now, I want to thank everyone who has already subscribed, and welcome to our recent newcomers. Thanks to Ken Paulus, Arnold J. Ladwig, Marius Daniel, Frederick Wellness, Gail, Andreas Dill, Rev Keith Carter, Edward Welbin, Mind Expansion, Nautilus Studios, and Alaskan Stout. Join the club at patreon.com/universetoday. All right, those are all the questions that we got this week. Thank you, everyone who joined me for the live show and asked me questions live here on the channel, as well as everybody who posted their questions into the YouTube comments. So I really appreciate that. Now, we record this show live every Monday at 5 p.m. Pacific time. So if you want to have a much longer 2-hour experience of the question show, come join us. There'll be a notification here on the channel. Subscribe to the channel, click on the notifications bell, and you'll be informed when we go live next Monday. Now, I'm going to talk about my recent trip to Japan, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, David Giltonan, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modso, Paul Rohrbach, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all our other patrons. All your support means the universe to us. So you're probably wondering what happened to the question show for the last 2 weeks, and that's because I was in Japan with my son. Now, this trip, originally, we were going to take 4 years ago in March 2020, but then the pandemic hit, and so we had to cancel the trip. And so we waited, and now we finally were able to do it. And I am so glad we got a chance to go back. Now, we didn't do any spacey, sciencey stuff. It was more going and seeing temples and shrines and eating amazing ramen and riding on bullet trains and just having a great time. But I'm so glad that I went, and sort of thanks to everybody who we got a chance to hang out with in Japan. The hospitality of the country is incredible, and just like the level of culture and organization and the food. So if you're wondering like, oh, I kind of am intrigued. I like anime. I'd like to maybe go to Japan. Do it. It's such an easy country to travel in. There's English on all the signs. Most machines that you can access, you can switch to other languages. Everybody is very warm and generous, and the prices are reasonable now, which I know is sort of hard for the Japanese economy, but for a person who is coming from another country, your dollar goes pretty far. So I'm going to go back pretty soon, I think. Take my other kid to Japan for a different adventure. So anyway, we're back with the show, and I hope to go back again and do more traveling. All right, we'll see you next week. Everything, yeah, okay. There is Cain spawn, 2 Cain spawns. QA 259. sake. All right, let me start the audio again. Whale omelet? No. No, I try to minimize the amount of sentient creatures that I eat. Hello, patrons. It's time for your overtime audio for QA episode 259 that was recorded on May 20th, 2024. All right, let's get into the additional questions. Your boys can swim. Yeah, my kids can swim. Have I told this story that so I live on Vancouver Island, and so we are surrounded by lakes and rivers. And one of my favorite things to do is to swim in rivers. And so when my kids were little, I taught them to swim because it's like vital. It's life or death knowing how to swim. I don't know. Here on Vancouver Island, surrounded by ocean, surrounded by rivers, lakes, and so on. And so I taught them how to swim in the river. And so learning how to swim in a river is a complicated challenge because the water is moving, it is carrying you. There are rapids, so you kind of have to learn to work with the river. And there's like very easy mode rivers that they were able to practice on, where you're floating down and you're able to sort of deal with, you learn how to swim at the right angle as you're crossing the river. And that did really well. So now they're both incredibly strong swimmers. They can swim through uncomfortable water and be fine and have fun doing it, which is great. So yeah, they swim a lot. Less now. Moonwalker, did anyone recognize you in Japan? Yes! I got recognized. So we were in Osaka. We were in this shopping district, and somebody came up and said, "Are you Fraser Cain?" It was like another foreigner. I'm like, yeah. I had my NASA hat on, and so we did a selfie together and chatted. And that was the only time that someone actually mentioned it to me, which was funny. But it happens all the time, it's unnerving. It's like that is the thing that I like. Fame is the thing that I'm most uncomfortable with. Like, I really love being able to help people and educate people and be able to talk to interesting people as my career and all of this. But the thing that I don't like at all is being like a public persona. Like, if I could be some virtual avatar on Twitch, it's kind of tempting. Corpse husband. But it's too late. And I understand, like, especially in this time of AI, that having a human being who is the one who is sharing this information is vital to know that you can trust somebody, until like OpenAI gets even better, and then they've got virtual human looking avatars with personalities. We're stalking you. Potato Biden, galaxies have ripples. The observations show a vertically oscillating disk movement like ripples in a pond. So galaxies do have ripples. So when you look at a galaxy and you sort of imagine the stars are just going around the center of the Milky Way, they actually have an up and down oscillation as well. So stars will go up and down and up and down as they're, and like when you think about the orbits that say the Earth versus Mercury versus Venus. Like, they're not all perfectly lined up on the plane of the ecliptic. Some of them are a little higher, some a little lower. And so if you sort of looked back, and you could see, like, sometimes Earth is a little higher, a little lower, and then as the whole solar system is moving around in the galaxy, then you're going to see these stars, you see the planets, at various levels higher or below the plane of the ecliptic. And so the same thing goes for stars, that stars are, as all of the stars are orbiting around in the Milky Way, some of them are going higher and some of them are going lower, above and below the galactic plane. And one of the sort of theories for mass extinction events in the past was that maybe the interstellar protection, all of the interstellar wind acts like this general protection that protects all planets and stars from the cosmic rays and the other sort of the interstellar winds that are going on. And so maybe there was a time when the sun had sort of poked up above the galactic plane, was less protected by all of the other heliospheres, and so that might explain why we had a mass extinction. And I think it lines up, like when the sun went above the galactic plane some X number of millions of years ago, then it might line up with when there was a mass extinction event. But there's not a lot of evidence that this is the case. Michael Nichols, if we think we have discovered life on a planet in another system, is it any easier or possible to build a telescope specific to examine that system only? Yes, in that the parameters of the star that you're looking at, the faintness of the planet that you're attempting to observe, that you could make sure that your telescope meets that certain minimum criteria. And yeah, I think if we found, but I'll give you like an example, like say the Solar Gravitational Lens telescope, where you use the gravity of the sun as a natural telescope lens. You send a telescope down this very specific cone which lines up the sun and whatever target is that you want to observe. And then you can only observe that one thing, but you get a 10,000 times magnification from the gravity of the sun. And so the solar gravitational lens would let a 1 meter telescope make a 1 megapixel image of an exoplanet that is 10 light years away, which is, we would require a 10,000 kilometer telescope to be able to make that same kind of observation. So that's a good example of where if we knew that we only had this one target that we could actually observe, then we could send the telescope out to the solar gravitational lens and make those observations. So, but in general, if you have like a really interesting target, the telescope that you build is going to be usable for anything that fits the same criteria. And so, if you have one planet that's 10 light years away, which is a Earth-sized world orbiting around a sun-like star, there's going to be 10 of those that you're going to be able to observe with the telescope that you build. But it won't be good for a lot. Well, actually, it would be good for a lot of other stuff as well. So, like in general, you don't want to get tied down, right? You don't want to just be forced to only use the one specific, one kind of observation. Like you want to be able to use your telescope for other stuff as well. There's so many things, so many targets. Levi Rivers, what do you think about the Apple ad that angered the world by crushing the technology and the things that computers have replaced bit by bit? Yeah, it was tone deaf. Like it was what they were trying to say was that you could take all of this audio production and all of this music production, all of this movie production and all this kind of stuff, and you can do it with this iPad. And I beg to differ, because iPads are terrible for content generation, in my opinion. Like it uses the Apple operating system, and it's terrible. Like Alt Tab, it can't move between applications, copy paste. You have to attach a separate keyboard. You might as well just have a laptop. Like use a laptop, like a gentleman. So, so I see what they were getting at, and man, like why? I think people are so nervous and upset about artificial intelligence now. And they're sort of expecting that the tech companies see the creativity and the things that people make as just grist for their mill to just feed into their endless maw of artificial intelligence. And that's true, right? Like, it is absolutely coming. I mean, we are approaching the content apocalypse for search engine traffic that has always been looming. You know, my traffic from Google search is about 10% of what it was 10 years ago. And a big reason is because, you know, if you search for what is the distance to the moon or something like that on Google, you're going to get just the answer. You're not going to get a web page that's going to talk about how scientists have more recently calculated the distance from the Earth to the moon. You're just going to get the answer and maybe some references. But once you get the answer, people just want the answer and they just move on. And so that has already existed for, you know, many years and has cut down the traffic from Google. And the next thing that's coming is they're going to have artificial intelligence give you a nice witty paragraph that explains, and it's fed by websites like mine, right? So if you want to read about Fraser's latest news, Google will gladly mash it down into a sort of, I don't know, an overview, a synopsis. And you don't even have to go to Universe Today anymore. And a lot of people are seeing this as like the final death blow that Google is about to drop, and all the various AI companies. And yet they're fed by our content. And I don't care. I don't see traffic from Google as a right, as an inalienable right that I deserve. It was a sweet bonus that we were able to take advantage of for while it worked. But as you see, you know, I write an email newsletter, I do a podcast, I put out an RSS feed, I maintain a website, I do all of, you know, Patreon, all of these things that allow me to make a personal connection with the audience. And my feeling is that when we do cross that line and a lot of the content on the internet is generated by robots for robots, then that human touch for a while is going to be a benefit. That we're going to have a team of human beings who are going to create, you know, content, and we're going to report, and we're going to interview people who are doing things years before this makes its way into the large language models. And so I think we've got another decade of us being able to create content that's better than the robots will be able to. And eventually there will come a day when the robots do my job better. And I'll know it, I'll feel it, I'll see it, and I will gracefully leave the field and hand over the baton to the robots. So, you know, I am against bad content, and I am for good content. And I think there's something kind of magical about artificial intelligence being able to create good content at scale, custom for every person who has a question about, you know, you've got a question about space or science or astronomy or whatever, and you want to have some tutor patiently take you through the content in a way that Fraser just doesn't have the time for. And if it's factually correct and it's not hallucinating and it's bringing in sources and it's doing a good job of educating people, then I am redundant and I will retire. I can't wait. That sounds great. Not the retire part. No, the patient artificial intelligence that doesn't hallucinate and provides good information. You know, because there's a lot of misinformation out there, and to have something that is doing a good job of being truthful, I think will be wonderful. But we're not there yet. And the problem is that people are deploying this stuff way too early. So what did I think about that Apple ad? It was fine. I don't care. It didn't bother me. I didn't get upset. I didn't get angry. I saw what they were going for. And I understood how people thought it was a little ham-fisted. And I don't like iPads very much. That's how I feel. Serious Kaylee, did you see the demo on ChatGPT 4.0? Sounds so much like Scarlett Johansson. Yeah, they're apparently the blowback has been so severe that they're planning on cutting the voice, that the one that sounds like Scarlett Johansson, but it'll be back, right? Like everyone was delighted by actually, not everybody was delighted. People were disgusted by this flirty, giggling artificial intelligence. I found it super cringe. I don't want my AI to talk to me that way. I want it to just give me nice answers. But the level of conversation was terrific, and the back and forth, and the ability to interrupt, and for it to be able to speak at different speeds and use different accents and speak in different languages, that all sounds amazing. Like I know my Mandarin learning will go up dramatically when I just sit with ChatGPT and just talk back and forth, and it's just guiding me and helping me, practice my language. So it's funny. I was on an airplane on the way home from Japan. I was sitting beside a woman who only spoke Mandarin Chinese, and so I chatted with her, which was pretty cool. It was pretty fun, and I was able to sort of help her order food and get stuff that she needed from the stewards. And she didn't speak any English at all. So apparently it has value. So that's what I want. That's what I want. I'll get access to the next version so that I can practice my language. Ryan, when will the QA from this live stream be posted? So we post the QA 8 days after. So a week and a day. So it's next Tuesday is when this episode will be live. Naked AI, Cain. Ryan M. Pearson, my son's school had space day today, and an astronaut aboard the ISS read a story to them. It was brilliant. That's amazing. That's crazy. Oh, good school. Good astronaut. Which astronaut was it? Nostalgia Arcade. I've heard you mention AI hallucinating a few times. Is this real, and what do you mean? Yeah, AI is a token prediction machine. So when you put in a question to AI, like, can you recommend, what are 10 websites that I can go to that will give me very specific information about modifying 1980s Nissans? Then it will give you 10 episodes. It'll give you 10 websites, and 7 of them will be real and 3 of them will not exist. Like if you go to type in that website, there will not be a website there because the AI just hallucinated it. It just made it up because it was very sure, very predictive. www, it knew that part. Okay, it's got that part. Now quick AI, make something up. And so it had to make up the rest. And so you get this just nonsense, 80s Nissan upgrades.org. And so for stuff that's like very well known, there's a lot of data in there. You ask it, where is the Eiffel Tower? It's going to tell you Paris over and over and over again. It's going to say it's in Paris. But if you have a fairly vague piece of information, then the AI could very likely just make something up. And it's very confident about it because it can only move forward. It can never just stop and go, whoa, whoa, whoa. I don't know the answer to this question, right? It just goes, I'm just going to make it up, and I'm going to stand by my answer with incredible certainty. And so that is what hallucinating is, and you just have to know that this is a part of the problem with modern AIs. They hallucinate. Alan Gross, will there be a QA with Fraser next Monday, U.S. Memorial Day? Of course, I'm Canadian. I don't take off U.S. holidays. There's a border. And we celebrate Canadian holidays on this side of the border, which, by the way, today is one of them. So happy BC Day, everybody. Everybody is taking the day off today, except for me. That's the problem with being a Canadian on the internet, is I don't get to take Canadian holidays off, and I don't get to take US holidays off. Thomas Quick, I'm a software engineer with 17 years of experience. Are there any ways I can help astronomy with my skills? Absolutely. A lot of astronomy, modern astronomy these days, is programming, computer programming. Like, a lot of astronomers are also very good computer programmers. There's tons of really good programming libraries in Python that astronomers have to work with. When you think about all of these like really big databases, Vera Rubin, upcoming Vera Rubin is going to be releasing petabytes of data onto the internet. The Sloan Digital Sky Survey, like a lot of astronomy, Gaia is giant database queries. And so astronomers are often limited by the amount of computer ability that they can do. And so, I don't know how to connect you directly with astronomers who need that kind of help. It'd be cool if there was a way to like connect software engineers with astronomers who need software engineering help. But it's the two just go hand in hand. So a thing that I recommend as a way to sort of cut your teeth is do some like data visualizations. Start to learn how to access where the Gaia data is, where the James Webb data is, where the Hubble data is, the Very Large Telescope, and do some interesting things. Like my friend Dylan O'Donnell, he downloaded all of the Hubble observations, just the right ascension and declination for every single observation that had been made by Hubble. And then he just plotted them on a chart of the sky. And that's how I got that 0.5% of observations by the Hubble Space Telescope, was that he counted up the total number of, all of the observations that were made in the sky just as a computer processing project. And yet he got a ton of publicity for doing that. So I think, there are projects that if you're interested in, you can go and find them. I recommend you spend some time getting to know the various Python libraries, the data sources, how the FITS works, the format that astronomers use to save their image files, and then like start reading papers on archive and look for times where people are referencing the kind of computer work that they had to do, and they go, I could help with that. And then you just have to start reaching out for people. And say, hey, I'm a computer programmer. I'm really good at giant database queries. I can SQL like nobody's business. Can I help you run some queries on the Sloan Digital Sky Survey? And, or, help you optimize your queries or whatever. And I'll bet you after a little while, you're going to have some people take you up on this. And then you're off to the races. Yeah. I mean, so much of astronomy now is computers. That, and then after a while, you'll probably end up on a team. Kevin Gill, who is sort of one of my favorite citizen scientists, he does a lot of the images from the Juno mission. He does a lot of renders of Mars based on Mars Reconnaissance Orbiter images, and he's able to import them into Maya and turn them into like 3D flyovers on Mars. And he's a computer programmer. He sort of originally he was a computer programmer, and he was doing all of these projects, and he got interviewed at NASA and now works at the Jet Propulsion Lab. He works for one of the Earth observing missions as a developer, and in his free time continues to do all of this image processing work that he does. So I think, not only can you help out and get involved, that a lot of these turn into jobs if you could bring a lot of value. So learn the libraries, learn the FITS format so you can download images from databases, and then just start making fun stuff, because astronomers are so busy with analyzing their data of trying to answer some specific scientific question that they don't have time to do the fun stuff. I'm going to take the entire Minor Planet Center database and I'm going to render all of the potential Earth crossing asteroids in a three-dimensional plot. And so now you see this real time thing of all of these asteroids flying around in space. Um, that's really cool, right? So there's a lot of these kinds of ideas that to take pieces of data and expand upon them in a way that has value. There's a lot of great ideas. So yeah, definitely, you know, become accustomed to the tools and the formats that they use. Come up with some stuff that tickles your own fancy, right? Like what if you took every star in the Gaia database and line them up by spectral class, and you would get this weird color, and you simulated the spectral class and you would just get this weird smear of colors, right? Because you've got all of these stars that are lined up and you could sort of start to see some patterns. So Damien Reload says Scott Manley did something like, yeah, Scott Manley's a programmer as well, right? Like, so Scott Manley in his regular job is a computer programmer. And so when a idea strikes his fancy, he can just code it up, which is great. So you're well positioned. All it takes is just a little bit of elbow grease, but I love it. Floater 81 floats. If money was no object, is there an upper limit in physics on how large an orbital capable rocket can be? No. I mean, I think you're sort of, after a while, you're wondering, like, how big can you make a skyscraper? Like, there are the limits. There's a point where the structural elements of your rocket are going to be so heavy that you really can't make a flight worthy vehicle. But when you think about the Sea Dragon, you could absolutely make rockets that are capable of carrying hundreds, maybe even thousands of tons to low Earth orbit. It's just who needs payloads that big and who's willing to put all of their eggs in that one basket. So, yeah, I'm sure there is an answer to that question, that that there is this sort of sweet spot where, but like as Elon Musk has said with Starship, that the bigger rocket, the more efficient, the more value you get out of it, especially when it comes to reusable. Moonwalker, did you stay in a capsule hotel? If not, would you try it for the experience next time? I didn't, but because the hotels were so cheap. We spent like $40 for our hotel rooms and they were great. They were fantastic hotel rooms. So, US, 40 US. And for like a single, and they're tiny, like they're smaller than the room that I'm in. Maybe 100 square feet, 120 square feet. So like bed, toilet, shower, bathtub, closet. That's it. And this much space around the bed for you to get around, but it's fine. Like, that's all you need. And so no, you wouldn't need a capsule. Like back in the 80s when hotel rooms were hundreds of dollars a night. Yeah, capsule hotel makes sense. But I know you could stay in capsule hotels for like $15 a night. But there's so many great accommodation options in Japan. They have these one-way hotels. So you check in at the hotel, they give you your room key, you go in, you stay, and then you leave and the door locks behind you. Because they don't give you a room key. They open the door for you, they let you in, and then when you leave, the door locks behind you and you're done, you're out. And so it's a one-way trip. But if you only need it for like 8 hours, then that's perfect. So there's so many. It's so flexible and civilized there. It was so much fun. Wait, did you get a camera upgrade in the last few months? You've been looking especially crisp. Yeah, too crisp. No, so I got this camera just before I went to Arizona, and this is my before I had the A7C, and this is the What kind of camera are you? The FX3. Yeah, this is the Sony FX3. So it's a very good camera. It's too good, but it does really two things that I needed to do, which is that it does 4K at 60 frames a second, and it has a rock solid autofocus. And so it's way more camera than I need, but but it's like when you do a lot of stuff solo, you just can't have the autofocus mess up on you. And I had my last camera before, I had a Lumix and a Panasonic Lumix, and it was an amazing camera, 4K, 60 frames a second, with a crappy autofocus. And so you would stand in front of it, and you could see the autofocus searching and scanning and putting you out of focus and in focus. And so it was useless. So you had to lock it into manual focus. And when you lock it in manual focus, if you make a mistake, then you're completely out of focus. But this one, like, I go far back, I'm in focus. I'm looking at when I look at the screen beside the camera, there's like a little box around my eyeball, and it knows exactly where my eyeball is. So I really like this camera. But ironically, like, I don't take it out on the road because it's just locked down on my desktop. And it's the best camera that I own. I bought the Osmo, the DJI Osmo 3. Do I have it handy? No. Oh, there it is. So, yeah, I took the Osmo 3 with me to Japan. So this guy, and it was incredible. So it's also 4K, 60 frames a second. Yeah. So let's see. So now it's looking at you. You're looking at it. And it like, you can see it sort of has this little gimbal. And it's amazing. So that Space Bites that I did when I was in Japan, I recorded with this guy, and I just put it on the table in front of me, recorded. It has a little lav mic that it comes with it. This is absolutely all a person needs to record on the road. It's amazing. It's a Van Dyke Nagotti. It is a Van Dyke. Where are we at? 6:38. Okay. I'm going to answer one more question, and then I think I'm going to go. Church discography. Will humans survive the next mass extinction event? We don't know. I mean, we are potentially in the middle of several mass extinction events right now. We are seeing a die-off of life forms on Earth, a loss of diversity. We're theoretically churning through Earth's resources faster than Earth can replenish them. And so who knows what's going to happen. But there's like a lot of different kinds of mass extinction events. An asteroid strike would be devastating, but I think humanity would survive, and eventually civilization would bounce back. Even the kinds of things that we're facing, a global nuclear war, some kind of climate change, all of these issues, they are bad, but they're the kind of thing that we can learn our lesson from and recover. But we're starting to enter into this era of the kinds of existential threats that we cannot recover from. So artificial intelligence is one of them, right? Like, if we do successfully make a life form that is smarter than us, how do you think that's going to work out for us? Imagine chimpanzees were like sitting around and planning to bring about human beings. Did not go well for them. We don't want to harm chimpanzees, although some people do and eat them, but they've lost their habitat, and because we want shopping malls and want to cut down trees and eat meat. So So that is definitely a potential existential threat. The ability for people to come up with like, and like I don't think there's a way you survive that. Like I don't think it's romantic like the Terminator or whatever, that you are fighting robots in hand-to-hand combat in tunnels. No, they just, you wake up one day and everybody's dead because the computers come up with a plan and it implemented the plan and just everybody dead. Everybody's dead. Or the computer just keeps rolling and doesn't care about us, and the Earth becomes less and less of the kind of place that humanity wants to live on, and the robots just don't care. So I think that is, that some kind of human-made biological thing, right? A pandemic, whatever, something that is engineered to cause more death and destruction. That seems like the kind of thing that could cause problems. And of course, there's some, potential for some science experiment. And there's another class beyond just mass extinction. There's a class of existential crises, which are kind of horrifying. Like, there's like us wiping out ourselves, or like a lot of humanity. There's us wiping out all life on Earth. And then there's like us wiping out all life on Earth and all future life on Earth, like by destroying the Earth somehow. And then there's like us destroying the universe. Like theoretically, if we unleash an AI horde into the universe that is unprepared, we sort of hand over the future of the universe, the future light cone of the universe, to the robots. So we're in this time when we got to be really careful, and the power for individual human beings to affect large amounts of the universe is growing day by day. Back in the olden days, you had to have some capacity of a nation state to build a nuclear weapon, and same thing with like some kind of bioweapon. But now, I mean, you can imagine 30 years from now, somebody orders all the right parts from eBay and builds a bioweapon and releases it because they've got a grudge, and kills all humanity. So it's a very interesting time that we live in. All right, that was fun. Thank you everybody for hanging out for the question show. Glad to be back. We will be back. We're releasing an interview tomorrow, and then I've got some other really cool interviews that are in the can. Space Bites on Thursday. Just steady as she goes. So we'll see you all next week. Thanks, everyone. Oh, and thank you to Zapfan and John Suffield for their amazing administration and helping me with the questions. So thank you, everybody. All right. See you next week.